some construction going on. Try to avoid that. Okay, now so we are going to start now, and today, as I have shared already, we are going to do Hdbscan, and that is another, like we have Dbscan, we have Hdbscan also. We'll see that, but before that, I'll just remind you a few things like clustering. We have done clustering k-means also and Dbscan also, but let us understand what clustering is. Okay, so we'll just explain with an example or understand with an example. Put the example here also, so let me do it. Suppose we want to understand the behavior of the consumers, or you can say that you want to understand the liking of the consumer so that you can actually plan your store. Suppose you are running a store, departmental store or something like that, and you want to understand the purchasing behavior of your client. Okay, so what you have to do, just it is just an example. Okay, it can be any other example, so you can correlate once you understand what clustering is. So the likely points are clubbed together and unlikely points are separated and put in another group. So we have a group, suppose we have a group of 10. We divide it in a group of 10, behavior of the customers, like the purchasing preferences, you can say, of a customer. And we have suppose 10 groups, because it's a store is big, so you can have 10 groups easily. And you have 10 groups of depending on the purchasing preferences of the consumers. Okay, so in these 10 groups, you'll put the people together who purchase a same or a similar product, right? So you cluster them, and that is what we call cluster. So there are two types of clusters actually. So if we have something like this, I put the, suppose we want to understand the purchasing habit of the consumers, we can divide them into groups. Let's say a group of, let's say 10 groups. Okay, so consumers having similar purchases will be grouped in a particular group, and the rest and so on. So most likely, we can say most likely in one group. This can help you to understand the behavior of the consumers. So clustering is actually of two types, hard and soft. We have this. So types of clustering, we have the hard one and the soft one. Okay, types of clustering, we have hard and soft. Something here, make it italics. Uh, okay, so we are talking about this hard clustering and soft clustering. Hard is you abide by the rules, exact match only in group one group, and the others in the other group. Exact match or very very close matches in one group. And soft clustering would be, okay, fine, this person can be in this group also, group one, group two, group three. Like if a person purchases not very frequently other product also, so that person can be in the other group also. So it is soft clustering and the hard clustering. Hard is you have specific rules, you have to abide by the rules, and soft is you can be little flexible. Okay, So let's there's a lot of theory to that. If we have we have different algorithms also for clustering, and we have seen already k-means we have done, and HDB scan, DB scan we have done. So there are connectivity models, centroid models, distribution models, and so on. Distribution model is your DB scan, and optics we have not done optics. Centroid is your key means where we find the center point, and then we have a distribution model also, that is normally a Gaussian model, which we have not done. It's not the course also, so we have not done that. That's okay, not required also. But these are the things I can put some theory here, so that if you want to read that, you can read it. I'm just pasting, so it is already there available to get it, get some relevant information for you. This is just for the theoretical part, and to understand the what clustering is and what HDB scan would be. So your HDB scan, 1 minute, let me beautify this a little bit. Okay, we have to put this also. Okay, now connectivity model we have. This one is the connectivity model. Oh, okay, I put the wrong thing there. 1 minute. Connectivity model is this. Now this is okay. Okay. And then we have the centroid model. This one is the centroid model. We find the central point for clustering. Central is more flexible point, you can say. We find this is acceptable limit. And the distribution point, that is where your DB scan comes in. Everything is on probability, right? So nee, this is Gaussian. Okay, sorry. This is density model. Is your uh, dB scan. That is what density is. Okay. That is noise we were talking about. Some isolations we have to do. So we have very density points here, and different density regions we have, and then we cluster according to that. Okay. So we can go through the theory part. This is what we have. So you can understand what clustering is and what we are doing. We are doing DB scan, as I've seen on the density model we are doing, and we have done this thing centroid also, that is k means. So we have done few clustering algorithms which are actually important and mostly used. DB scan, SDB scans, they're relatively newer to k means, and not much applications you will see, but they are very very handy uh, and easy to implement also. Okay, so let's see. Let me put something about HDB scan also. So we have the link. Let me share the link also for you guys for HDB scan. That is the documentation of HDB scan, and I'll just put it here at the top, or I'll just remove it. It's not required here. I'll just remove HDB scan. We'll just put the clustering here, and HDB scan will put in a separate thing, because I started with that. But anyway, okay. Now I'll just share the link also. This is the documentation link. I'll be just giving some simple examples and see. And we have to cover the mounting also today. So how to we can share the data sets, mount on the drive, so that you don't have to load it every time in Colab. If you're using PyCharm or something else, then you have the folders where you can put, but not here. Okay. But anyway, so we have done this part now. your Hdbscan. The link is already there. Okay. So if we have some data and we want to cluster it, how exactly we want to do it, that depends on the thing we want. It's like, suppose we have the results, we know this result we want to have. Okay, so but we some in some cases, like I told you, like in suppose I want to understand the behavior of the customers, I don't know the output. Okay, I don't know what output I would be looking at. Okay, so we will be using a sklearn for that, and implementation goes there also. And let me put some, the link I have already put, so let me put something else, and the syntax and all I have to put. So anyway, we'll have a sample code and see how it works. So, so we have to create a data frame. We will create a data set and then just pasting from the documentation only. So we have to create a data set and data frame. First we have to create a data frame, a clean data frame we have to create, and then we can add things. Okay, so let's do it. First we have to see it is there or not, it is the module is installed or not. So I have to check that also. So from sklearn we have make blobs. Okay, so we will have 2000 samples and 10 features. Okay, number of features will be 10 and number of samples will be 2000. It can be anything, it's not necessary, but it is given in the example, so I'm using the same example. So let's import from sklearn, from sklearn dot data set, we have to import make blobs. Data sets, import make blobs. I'll run it first. I hope there's no spelling mistakes, but let me check by running it. Typing errors can be there, so it's always better to check. Let's check it. First time collab always takes time, we know that, and we needing pandas also because we need the data frame. So we need a clean data frame. So features we know, and the samples we know. Okay, it's done. So no mistakes. Import pandas as PD. This is also done. Now I want the data and the blob, the labels. So we can have the blobs of the data and the label. I'll just put data and labels. Let's not confuse. The example says blob, but let's see how it. Make blobs is the module we have. We already have that. And here we know that number of samples, so we have to give is 2000, can be anything. And number of features we have to give, that n features is equal to 10. And let's see what we get out of it. Data we have now. First let's convert it into the data frame, and the data frame is equal to pd dot data frame. Just put the data there, labels not required. Sorry, labels we can add also, that's not an issue. Now let's have df dot, and let's see what we have created. So we'll get the data if there's no typing error. Yeah, so you can see 0 starting from 0 to 9, that is we have 10 columns, 10 labels. Labels are there automatically given, and then we have the data here. Okay, you can print the data also, so the label also. Labels, you can see that 0, 0, 2, 2, that's a randomly given labels, so they can come in also. Like we are not taking labels, we are just taking the data, and we get the data frame automatically. Headers will go, column headers will go. Now we have to import Hdbscan. Okay, then we need the clusters. Hdbscan, I hope it is correct. Hdbscan. Let me see if it is there or not. If it is not there, then I'll have to import the module. To be example, no module named Hdbscan. Okay. I hope I have typed it correctly. It's not there. So let's install it. So if you don't have the module, you'll get this error. No module named Hdbscan. Okay. So let's install it. And for installing in Colab, you have to use an exclamation mark, then pip, and then install Hdbscan. Okay. You can install it. If you're using PyCharm, then there's easier way of installing it. If you're using Jupyter, same method. If you're using Spider, same method. That is exclamation pip install Hdbscan. If you're using command prompt, you just have to say pip install Hdbscan, no exclamation mark required. So they whatever way it is always pip. Pip is always to install your modules, and which version you want to install equal to, you can give the version number also, but by default it will be the latest version which will be installed. In some cases, uh, when we install the latest models or modules, you can say, then the codes we are having don't run because they are not designed for the latest uh, module. There may be some changes which were not incorporated in the code which we have, like we search it on Google, we find some code, we want to run it, it doesn't run. Although we have the module, it is all because of the version of the module, nothing else. So you can remove pip install the same way you can remove the module, install the version which uh, is required for the code you want to run. Okay, so installation, collected packages Hdbscan successfully installed HTTP 0.8.28. You can see the version, it is 0.8.28. Okay, now let me install run this command again, and now it's fine. So you don't have an error now. So the error goes as soon as you install the module. Okay. Now let's what we do is we fit, right? We have to create the cluster. So let's have the cluster or the model. We can have the cluster since we are clustering. So we'll have the cluster data we have. So we can have edge data dot. So we have PDF. I think it is not HTTP scan. We have okay. Okay. We have HDB. Also, we have to first of all we have to create the object. So HDB scan. Oh, HDB scan dot HDB scan is there. So we have created the object. So we can say create object. So we have the cluster now, and we have to put it on the data or data frame we have created. So we'll put it on that. So we have cluster dot fit. Let me try it on DF data frame I created and see, otherwise I can put it directly on the data. That is this data. Okay. So let me run it. Alright, this perfectly fine. Now so we can fit it on this, and then we have to get something like algorithm. We can define the algorithm also, and then we can cluster the labels. Check. Let's see what we get. Yeah, we have the labels here, and we can have your Hdbscan here. We have the module also, so we can have the maximum of your labels like this one. We can have something like this dot max. We can have something like this. We can have max is 2, that is the label given is maximum 2. So we have total 3 clusters, 0, 1 and 2. So it is a noise aware module, and I'll just put some 3 for you. I'll just put it here. Okay, we have a cluster of we have 3 clusters with label 0, 1, 2. It is noise aware. It has a notion of data samples that are not assigned to any cluster. So it has that also. This is handled by assigning these samples, the labels -1. So there's no -1 here. So there's nothing like which is not assigned. So, but we can see that probabilities. We can find the probabilities and see what it gives. Okay, cluster. Sorry, this cluster. Yeah, not probability is as fine. You can see the probability. I've already put what I mean by that. Then we have the different matrix like clusters, Hdbscan. We can have another matrix by default. It would have taken a like a best algorithm, and the matrix could be anything. I can change the matrix if I want. We can have a different matrix. So you can change that to Manhattan or something. There are many matrices which are there. Okay, so let me put it like this also. We have the cluster already. Cluster. I have a cluster, so I can what I can do is I can have some other cluster and put it there, so it won't actually override. It's not there. I know it is not there. Hdbscan. By default, we had taken Hdbscan earlier. We had taken the default thing, but now we are taking something else, and we can give matrix equal to Manhattan. I hope I have spelled it correctly. Manhattan, yeah. Hdbscan, it is giving me some error there. Hdbscan is okay. Why it is giving me error? Hdbscan is not defined. Hdbscan is defined. Let me copy this from here. It is already imported. It should not give me any error now. Why it is giving me error? So let me, maybe some typing mistake. Yeah, that's fine. So you can have different methods, and we can have the cluster.fit. We have cluster.fit data frame, or I can put the data also like this first. And suppose if I put the data directly without getting the data frame, it gives me the same result. So it doesn't matter. So we have then we have cluster. Sorry, we have not cluster. We have cluster RER. Using, so let's fit it and see. That is matrix. It is giving me as Manhattan. So I don't have to check this now. Anyway, and we have the label dot label. Yeah. Let's run it. So we have an array again. Similar, we can have the maximum value also of the cluster you want to have, and we can have the distribution matrix. You can see what all we have with the matrix. And suppose to have, we can have that also. So let me see if we can generate that. Matrix map should give me the matrices which can be used. Hamming windows, Euclidean distance, dice, cosine, city block, Chebyshev, I don't know, Arcos, then break, Curtis, Canberra, Chebyshev. This Chebyshev must be some Russian or something like that. Then Infinity, Jakarta coefficient is very common. Manhattan. Then we have Jakarta is we find sometimes in images. We need that. So we have many and more or less they look like more some Russian names. So you can have. Okay, so you can check it that what matrices are allowed, which matrix you can use, and see how it works. Okay, so we have the distance matrix also. So we can find the pairwise distance between the 2 points, you can say, and we can get the things done. Okay, so we have this is the simple example we have. We can use some other examples also and see how it works. Okay, so let me get to some other thing like outlier detection. We have the data with us, so we can do that. Let me see. We have a digit data set, so we can have something like this, and let's see if it works. Data set we have already imported. Let me check data sets here. Skillando data sets, import make blobs. Let me see if it works directly or I'll have to import something. Oh, it doesn't. Data sets is not defined. You cannot have directly. Actually, it is there, import is there, but we have not imported it like data sets only. So NumPy, we can use NumPy also. And then let me do this thing. Hdbscan, NumPy, we can have Seaborn, we can have, and then we can NumPy.log load and see if it works. Let me change this and we can put something else now. Let me see if it works. Data we can have now. You can see the shape. Data. We can have any of that. It is not working, so see if it works. No. So no such file directory cluster label data NumPy, because we have to import actually, and we have to use the data sets actually, and I'll have to download that basically. So it is not there, or I have to give the entire path for the data. We have the clusterable data already there at a site. We have that, we can download that from there, but it won't work as directly, so I have to import some data and work on this. So let me see if I can get something better. But for all this we need the data sets. We can have data set. So we can have learn as data, we can have that also, and then we can create the data. So let me change few things here. Imported from sklearn, so let me do that first. Let me see if I can upload this data. This one is fine because we have data sets as data. Earlier it was data sets as something as make blobs. We were importing make blobs, but we are importing data now, so it should work. Let's have this example now. I'll put the critical part. We're just creating some sort of data and trying to see the plot, how it works, how it behaves. This is just a simple scatter plot. Then we have a data size and all we have to see, and we have to see. This is just a simple display of the data. Now we'll import your Hdbscan, and then we have the clusters, and we see how it works. It will be the difference. So we have the cluster as we did earlier also. So Hdbscan minimum cluster size is 5, general minimum span tree is 2. That is spanning tree, what you want to give here is 2. And we fit the data cluster dot fit. We have the test data here. Test data is np.vstack. That is vstack is vertical stacking, putting the data vertically. Okay, so I've not displayed that data. Let me do that. Simply putting it here. I should display my data also. So this is the data which is there. Okay, we can get the shape and all we want to print that, and we know the commands to print the shape and all, so that is not required for now. Now let me run it and see. We'll get Hdbscan. We have the spanning tree is there. Okay, so we can do things like this, and we have we can create the minimum spanning tree, and let's try and see if we can draw this. Yeah, we can create this minimum spanning tree with the plot edge viridis edge alpha 0.6, node size 80, edge line width as 2. So you can create uh, a minimum spanning tree, and we have the algorithms there. So building you can create a minimum spanning, then build the cluster hierarchy. You can create the cluster hierarchy also, how the data is clustered, what is the hierarchy of the clustering. We can have a cluster, that is what the data was, and a dot single linkage tree plot. CMAP is already there. You can see how the clusters are placed, or what is the hierarchy of the clusters. Okay, so you can put the hierarchy also. Cluster, this is called cluster hierarchy, and I'll just put that here. Let me put cluster and hierarchy. Okay, this is cluster hierarchy we have. Practical applications you can do, so you can apply in the real data sets, and you can see how it works. So we can put that, and what else we can do? We can condense also. We can condense the cluster tree. We can condense the cluster tree. Oh, this is a data set which is generated. You can create your own, use your own data set from a CSV file also and apply on that. And you can see it later, but for now we can see a few plots and see how it works. And then we can extract the clusters also if you want to. And all this will give me actual information about, let's say, if we are talking about the consumer behavior, then it is going to give me about the consumer behavior. Extract. Oops, that was to be here. And drop it. Okay. See the extraction of the clusters. You can see it is marked. You can see the data can be more meaningful if you use a real-time data set, and you can create a better understanding, and we can have a distributed clustering, something like this. That is what we are more used to, like in k-means. We can have something like this also. Okay, this is what we started with, similar to that. So palette test and as that is Seaborn we have used, then the color palette we have used. It is just a distribution of the data we created, test data and the 0 and 1 that we have created, and plotting the thing. And you can see this is something similar to what it was. It was connected, and this is what it is. So we can have and we know that the probabilities are between 0, the values are the labels, you can say that 0, 1, 2, and labels are 3 or 3 rather, and then -1 will be out. That means it is not clusters. So any point not in the cluster will be, I'll just put -1. Okay, let's put some theory to it. I've already shared the link, so you can have the details from here also. So this is the documentation part only, and we can see how, if we can use it in a real life. We can create a data set or import a data set, and then we can do that also. Okay, so we have the clustering data sets we can have, or we can import some data sets from distance data set from Skippy or sklearn. We can do that. Okay, so again we can plot it and see. We can have the distance based membership also, so we'll have a look at that also, and how it behaves. But it is all about basically getting to understand how closely the data is linked with each other. The clustering is, that is what the clustering is all about. Okay, so we have this, and let me first share this with you. Let me save this. I'll share this work or notebook with you, and we can have some more examples. But let me share this with you so that you can have a look at it. The link I have already shared the link for Hdbscan, and you can see some data sets and how the things are behaving. So let me share it with you first, then we can continue. Okay, so let me share.